last we spoke, we were in mid-sentence doing the vector, also called cross product of two vectors, exploring that definition. And we were doing the component form. I was getting pretty hasty there, so we get to slow it down here a little bit and talk a bit about the right-hand rule. Okay. But again, like anything, the way to learn this is to use it and to do those exercises and those homework problems. AX I hat plus AY J hat plus AZ K hat, using this rule and multiplying vector B, whatever it may be, and now we can see what we get. Now what we're going to get is what I said before. When it's in alphabetic order, X, Y, Z, Y, Z, X, Z, X, Y, then it's positive. If the permutation or the ordering is flipped, it's going to get a negative. Why? Because it's useful. It works out. You'll see how it all works out. Don't even overthink that now, okay? Because you can't see the subtlety until you go there. All right, so we do this again. Multiplication. Any algebraic multiplication like this is just take the first term and multiply it across. Take the second term and multiply it across. I'm not really big on that whole FOIL thing, you know, where you have A plus B times C plus D. Just take A and multiply it times that, and take B, A times that, and then take B and multiply it across, and multiply it. And you can do that for as many as you want. So now, though, our rule, look like a minus sign, our rule is the one that we're exploring. Very useful. I've tried to motivate that it's useful. So what do I do? Well, where are my zeros? A, X, I hat, cross. These are parallel, and we want to multiply perpendicular parts. So there's my 0. This guy times that's going to give me a 0. And this guy times means vector, also called cross product. So what I'm left with is my AX. So I got AX, I hat, cross, BY, J hat, plus AX, I hat, cross, BZ, K hat. Now it's a mess. You know, it's a mess. So that's kind of whatever. Deal with that. Plus, and then I got to do AY. Let me just write that a little more efficiently. AY times the X and the Z component of B. And then I got to do can we get this in there okay? Yeah. Stretching it out there. Okay, so you get the idea. And again, these are just amounts. So that's AX BY times I hat cross J hat. And so that's K hat, X, Y, Z. This is AX BZ I hat cross, cross K hat. Hopefully you get this. X, Z doesn't come after X, so we need a Y, J hat, but it's a negative. And you can do that with every term, and it doesn't even, not even useful to look at this, to watch me do it. You should do it. And you just get that familiarity. So let's go over here. What I've done is I've taken the unit vectors and put them out front. I can just write this. If I want A cross B, I just write it like this. I go, okay, I know it's a vector, so I'm going to have X component, I'm going to have a Y component, and I'm going to have a Z component. I'm adding those up, but they're vectorial, so I can't add the numbers up. They're perpendicular. So what do I get? X, and then I just do this, AB minus AB. AB minus AB, but they're components, so which ones? Well, I just I don't even think, I don't even know what I'm doing. I'm following a rule. Fine. I go x, what comes after x? Y, what comes after y? Z. X, Y, Z. Negative means I flip these guys. Now A is Z times B of Y. It's messy, just write it out and see how it goes, right? Y, what comes after Y? Z, what comes after Z? X. Y, and then I just take these guys and flip them. X, Z. Z, what comes after Z? X. What comes after X? Y. When you flip them, Y, X. You try not to make a mistake like I did in the last one as I caught it though, right? Just looking at that. What does it mean? Depends. Are you talking about magnetic fields, electric fields? Are you talking about torque, angular momentum? It's all good. It'll all apply. And then we'll look and see how that jives with our intuition and what we're really talking about. They're very useful rules. It's great. It's a nice shorthand. It allows us to end up calculating stuff that we couldn't keep track of all the factors in our head. And so that's pretty much it. There's one last step. That's how you'll get the answer. But there's another way, and we often don't do this, at least in lower division. In upper division, we tend to do this a lot. So I found in my upper division graduate work, you could write this as a determinant. If you know how, that's fine. But I think for me, I just write this out, and then I look at the vectors A and B and just put in what I know. Some of those hopefully are zeros, and go for it. And so you can do it very fast. Last little bit is when I'm doing the vector, also called cross product of two vectors. This is a nice one too. The amount is just the magnitude A times the magnitude of B times the sine of the angle between the lines of the two. Fine. And the right-hand rule. We haven't talked about the right-hand rule direction. So let's get that right-hand rule direction down as best we can. You're going to need some practice. There's probably tons of stuff on the web for this. I just wanted to put it all in one grouping and do my spin on it. But the right-hand rule, again, is just a definition. If we were mostly left-handed, it would be the left-hand rule. So then we have to write our experimental results in terms of that rule. So here we go. The right-hand rule is this. It gives us a direction. Now, we can get it out of this, but you got to admit that's kind of messy. So this is a pretty nice one. The right-hand rule goes like this. There's multiple ways of doing it. As long as you get the same answer, whatever trick you use is fine. So let's do this. Let's go back to our A cross B. Now the interesting thing is, the result is, remember we're multiplying perpendicular parts, and we're going to get a result, A cross B, that is perpendicular to both of these. Any two vectors form a plane. However you spin them, whatever direction you do, any two lines will form a plane. And so the result of A cross B is perpendicular to that plane, either this way or that way. It's vectorial, so there is a plus. One way is plus, one way is minus, or there's an opposite orientation. So which way is it? So what you do is you slide these guys tail to tail. And again, let me show you multiple ways. That forms a plane on the page, so the answer has got to be out of the page or board or into. I'll give you some notation here to remind you. That is like a vector coming out of the page. So this is out. And here, so this is the vector arrow tip. And this means in because this would be the arrow tail feathers. Think of a bow and arrow, whatever. So this means in, that means out. You just got to invent a notation. All right, cool. So A cross B, it's right-hand rule. So if we're right-handed, it's even harder because we left-handers got it easy. You can write with your right hand and do this with your left. But put your pen down, use your right hand. I could imagine pushing A into B. If I push A with a flat hand into B, again, lots of ways to do this, A into B, or you can think of it curling, pushing or curling. If I put your palm there and my thumb is out, that's the direction of A cross B. A cross B would be out. So I'd make the out symbol and put it right there, whatever it is. A cross B. What direction is B cross A? Well, now I got to push B onto A. Push it on, curl it on, whatever you got. If I flip, then I've got to flip my hand. And this can get really contorted here, but B cross A is in. How much? Well, in both cases, the amount is AB sine theta. So that's one example. Okay, let's look at other cases. Oh, let me give you another way of doing this. Screwdriver. A screwdriver should have a screwdriver here, but here's a screwdriver. If you turn a screwdriver so that A rotates into B, that means you go this way, A into B. And if you have a sense of how a screwdriver works, the right-handed screw will come out. If you go B into A, the screwdriver will go in. Now here is the one that I find students, when they get it, like the best. And there's variations on this too. The first vector for A cross B is A, number one. The second vector is B. And you don't have to worry about the angle because that makes a plane. You put them next to each other. So however you do that, that makes a plane. And you've got to end up perpendicular. A cross B is that way. Now B is if I do B first, B, A, into. I get the same result. So notice that those are perpendicular directions, and the angle between A and B doesn't matter because it'll still make that same plane. So I think that's a pretty good tool, and that's the one that I often like the best. Any of those work. It's really actually you learn it best if you know them all. Let's try another example. Suppose I've got A this way. Which way is that? Well, the tip is coming out, right? And suppose B is this way. So what direction is A cross B? You know, it's a little bit tricky. Let's make that A, and there's B. So I've got to be picky. A is this way. Oh. B, 1, 2, A cross B. You can't do this. You can't be sloppy on this. A cross B is perpendicular to this plane, the plane of A and B. And so the result here would be perpendicular to both, or A cross B, with an amount AB sine theta. And what if I do B cross A? 1, oh man, that's going to be hard. 1, A, B cross A. Oh, good luck. Right? So whatever. But hey, wait a minute, it's just the flip of that, right? So B cross A is the other way. And check that out and see, you know, you could push it, you could do whatever you want. So what happens if I flip A? If all of a sudden A is inside, going into the board. Well, prove to yourself that if I flipped A, then I've flipped these guys. So now this would be A cross B, and this would be B cross A. But still, it's perpendicular to that plane. So that's what we mean by the right-hand rule. Direction, you can do it this way, and you get the answer, which is consistent with your component form. But yuck, the component form is, you just don't do it unless you have to. This way is kind of nice, and that gives you the answer. And again, the result is always perpendicular to the plane formed by these. In this case, what's the angle between A and B? It's 90 degrees, because one's into the board and one's along the board. Right? So however you do that kind of stuff. And you just got to practice it. That's the only solution. It's a rule. Learn the rule, and the wisdom of inventing the rule will come with time. If you want to do any more, I just work some more examples, see them in your book. Work it out. I like the 1, 2, 3 kind of thing here. Any other insight I can give you? I think that's pretty good. Just try it out. Here's A. There's B. What's this? One little bit. Let's make this A, and let's make this B. Now, the weird thing is when you add vectors, of course, they have to be the same thing, like length has to add to length. Velocity has to add to velocity, or subtract. Acceleration has to add to acceleration, force to force, momentum to momentum. Right. In this case, we're multiplying vectors, so you can multiply anything times anything. You can multiply velocity times a length or a displacement, like what does that mean? I don't know. But, so we're going to look for useful ones. So we can multiply anything. So the lengths we can't even compare. I can't compare the length or the magnitude, the amount of velocity, the speed, times the displacement. I can't compare those lengths. It's kind of an interesting thing. So I'm going to slide this guy up here. Actually, I'm going to slide this down here because it's kind of a mess. Keep that angle here. Okay, so here's the line of A, remember? And here's the line of B. And what's the angle between those lines? Well, the angle between A and B, you might say, is that. But it's also that. Either one is the angle between. For the case of the vector cross product. Why? Because the sine of theta is equal to the sine of 180 minus theta. So that's fine with the vector product. I'll just write that over here. But is that true for the scalar dot product? Well, let's see. The sine of theta is the same as the complementary angle. But the cosine of theta, what about the complementary angle there? Is that true? Try it out. Test it. Let's see. Try about 0. Cosine of 0 is 1. Cosine of 180 is minus 1. And you can look on a unit circle and see that that's true. So this is not directional when I do the scalar product because I'm getting a scalar. And the plus minus of a scalar just means more or less than 0. Plus minus of a vector has to do with direction. When you're dealing with a sine, it doesn't matter which angle you use. Okay, I think that's a good introduction, and then you just got to use it to learn it. Okay, let's get on with some physics.